computer. And I think, where's, okay. So, hello everyone. I'm gonna just give a tutorial about what I know about how to work with Spot. And a disclaimer is I sort of tested everything on Wednesday, but I haven't touched it since then. So it's possible that something doesn't work, but you can get the idea of what I'm trying to say. So there are a few things I want to talk about. So like starting from the very basics of networking, like just how to connect to the robot, and then like how to use Spot SDK, like what it is. So the Spot SDK is sort of like the package that Boston Dynamics provides to you to interface with the functionalities on the robot, and then walk through a Hello World example. And then I try to like sort of talk about how to figure something out, like besides having the impression of what Spot SDK looks like. If you have something that you want to do with Spot, like how would you go about figuring that out? And then finally, this robot dev is something that I have sort of like been working on that makes it easier to work with different robots. And it's a bit tricky to set up, but once you have it, there's a lot of like functionality already there. So I'm gonna do some demo about that at the end. Okay, but before, actually, Sergio isn't coming. I'm gonna send a video to Sergio because there's something that I wanted to that sort of is related to what Sergio was posting. But anyway. So before diving into anything, the first is Spot logistics. And some of you may know, but some of you are new. So so we have two spots. One, so they have like numbers on the back, and we didn't give them names, but we sort of identified them by the last two digits. The one over there is 202. The one over here is 12. And okay, so we have two spots. And then what happens is like they can fall when they're charging, or like there's some piece that can just fall off. So there are a lot of unexpected things that can happen. And when you work with a robot, like I think what you could think about is like any any bad, I guess the point is like basically any bad situation that you can imagine may actually happen. So and here is like an example of some weird things. We didn't expect the robot to like shift when it is docking. And here's another example. This is this is why I hoped Sergio could be here. But basically, I'm showing a video he posted on LinkedIn, and it's essentially the robot is wobbling, but we didn't know about this until I saw this on LinkedIn. So it's I guess it's not, it's at least you should like let the other people who use Spot know about this. And if there's a problem like wobbling, it's definitely unusual. So we may want to like actually contact the support. And the sort of like some rule of thumb or a set of like steps to refer to when you encounter any accident, what should you do? First thing is to calm down and acknowledge the problem, and then take pictures and videos. That's what Sergio did. That was good. But then you want to like also inform people on Slack instead of at least before you post it on social media. And then you also want to act. So at a scene, if you see an accident, you may, usually reboot the robot and then try to let it like stand up again. Or I guess like maybe sometimes you have to like manually grab it and then like move it around, but you need to do something. And what happens probably is we are gonna reach out to support, and then they're gonna like contact us. And if you were there when you saw the accident, I hope you could stay in the loop. So In most cases, Spot is fine, like, but you never know when it's a robot. And I have had pretty good experience with the support team. Like, you sort of just email them, and because like we have the license, and as a part of the deal, they sort of provide the support. So they're pretty responsive. And so besides like sort of how you handle accidents, here's how like we sort of figured out like how we work with new people getting on board. So first you sign up on a spreadsheet that let's see if this. So this spreadsheet of like people's names, and then there are like a few different roles. So there's like a supervisor and independent user who just like doesn't need to require supervisor, or a user who's like basically, if you want to use a Spot, there should be a you should have a supervisor present. And if you're a new member, so like you're just getting started, and then besides the spreadsheet, join Slack, and there's a channel for this, and then join the calendar, and if you're a new member, you should go through the safety training and a quiz. So the safety training is on the wiki page, and it's basically like a bunch of steps, but also like a video list, YouTube list of videos that you should watch. And also there's a quiz that Eric made. That was pretty nice. There's like a lot of these are pretty detailed. You can only answer if you actually were paying attention in the safety training. So okay, so this is logistics. And also, okay, so if you're a user, you want to become an independent user, you need approval from a supervisor, and then you should block the time on the calendar when you use the Spot. That's so that like just for consistency. And that's the logistics. Okay, Vivian. So I guess if you want to like become a new member, just like talk to someone. And yeah, and then after you are done with safety trainings, you can become a user who can use Spot. And then if you talk with a independent, you're sort of like, I guess, go through some, like get approval from a supervisor, so like make them trust that you're able to handle, and you can become an independent user. So. And then, okay, so the first thing is networking basics. So there are 3 ways to connect to Spot. One is through the Spot's built-in Wi-Fi. If you access a broadcaster, I don't know, access point of Wi-Fi, or mostly we connect Spot to the RLab, or you can use the Ethernet, and they have different IP addresses. And then the thing is like they have different sort of performance or latency. Like here's a sort of experiment that I run a while back, and when I'm sort of streaming depth and sort of like depth images and also color images from all cameras at the same time, this is what this is like showing. So if you use like Spot Wi-Fi, higher is slower, so like 4.5 seconds or something like. So higher is slower, and if you use Spot Wi-Fi, it's the slowest. And if you use Ethernet, that's like the orange thing, that's the fastest. But if you use RLab, that's like pretty close to like Ethernet, but also like much faster than the Spot's Wi-Fi. That's why we're using RLab for the most part. And also like how, so once you can sort of connect to Spot via like internet, you can also do system administration. So this is like an interface that you can log in and then like do some maintenance. So there are 2 types of users you can log in as. One is like just a user or an admin. And if you're an admin, then you can do user management and software updates. But most of the time it's sufficient to just be as a user. And I was gonna show how this is gonna work. So if I type in user and then I remember the password. Yes, I hope. So this is sort of like the IP address of that Spot, and it is waiting for, yeah, so this is where, okay, nice. So this is like the interface, and you can do many things. You don't need to like remember any of this. That's why we have a recording. So network setup, you can do Ethernet or Wi-Fi, and you can like change it to like access point or client and stuff like that. And then exactly. So because I cannot see yeah, okay, no problem. Yeah. And then another useful thing is like when you contact support, it may ask you for logs, and then there will be like logs that you can download from this tab. And then payload. So if you sort of like want to install like LiDAR or something like that, they have documentation for these things. I'm not going to go through every single one of them, but that gives you an idea of like how how to like do system administration. The thing is that you cannot access the built like onboard computer on Spot. That's like with closed specs. You don't know what it is actually running, but you can also only like sort of control it through this interface. And okay, so that's this. So you okay, use this administration interface for network configuration, payload configuration, logs, or Spot license. And then there's always like official documentation. So like the page looks like this. It looks like it gives you like pretty good step-by-step guide. And most of the time it's like really clear what it is trying to say. So okay, so that's like the networking basics. And the next thing is actual like programming SDK and a Hello World example. So you will have like sort of like a different kind of support website, but this is for SDK. It looks more like a documentation for a Python package. And it is essentially like this Spot SDK is a Python package. So the big picture is you have Spot and you have like your own computer, and there's a computer running, or maybe two computers running on Spot, and then you don't know the specs, and there's no SSH. So it's really a black box. And what happens is, okay, so essentially you communicate with Spot through gRPC, and Spot runs gRPC server that provides a bunch of different services like getting image or get robot state. And then what you do is your application sort of like communicates with that server. Your application acts as a gRPC client, and that client sort of uses this SDK to make like this interaction easier. And what this SDK is a collection of Python client objects and helper functions. So I'm gonna sort of like give a super quick overview of what gRPC is, so that like you don't leave without like a hole in your knowledge. So gRPC stands for Google Remote Procedure Call. It is simple, a simple and cross-platform and general purpose sort of framework for communication between like servers and clients. And the way it works is you define like your interface or message types for the communication through this thing called through a file with extension proto. It is essentially like a language called protobuf. And what happens is you have like an organized set of these files, and in each of them you define the services and message types. So to be more concrete, here is like an example from the documentation. So what you see is you define like let's say like you want, this is like the most basic example. You have like a server that wants to say hello to, actually a client that wants to say hello to a server. And then you define this like service called greeter, which has like two kinds of like RPCs that, so like you can think of RPCs like methods that you can call. Like say hello is like a thing that the client is able to do. And it defines, so the input is the hello request, and output is a hello reply. And each of like these are basically messages that are being sent. And then you define the message types here. And that's also like what's going on with this like protobuf thing. So it is not defining like exactly how to implement the hello request, but it's just defining like the interface of like what input I need to make this message, and then what kind of functions I can call. So what you see is like, it's really useful that the Spot SDK gives you a page that lists all of the protobufs that it's providing you. And for example, let's say like there's a robot state proto. So robot state proto sort of like defines, like these are like message types, like battery state, and it has like different fields. So yeah, basically this is really useful to like see what Spot can do at a lower level. And then okay, so what I was gonna show is on the GitHub repo, I'm gonna show you like how you see the like how like a in like sort of like a prototype is implemented in the Spot SDK. So this is like their repository, and you're most likely gonna like clone this when you work with Spot. But there is like, let's say like this service called robot state, and there is this proto file that you can find in this repository that sort of, okay, so it's really simple here. It's just defining like a single robot state service that has a bunch of like RPCs. And then it actually, like the way that Boston Dynamics is organizing this is like, they have like this other thing called robot data proto that doesn't have services, but just message types. So yeah, this is sort of just give you an idea of like, if I want to find the definition of like robot state request, I'm probably gonna find it in this file. Exactly. So, and then those are like protobufs, which are like sort of abstract, but concretely, what you will actually interact with is like, this is part of the SDK, and there's like a class called robot state client, and essentially the robot is running the server for the robot state service, and you are using this client to talk to that server. So basically, there is this like get robot state, which I believe is one of the RPCs. Get robot state, yes, exactly. So basically, get robot state is like in Python, it's like this is the method that you call, but fundamentally it's like calling this get robot state RPC. So that's how you may interact with like the gRPC server. I didn't really time any of this, so maybe if like runs out and you need to leave, that's fine. So how do you use Spot SDK? Now knowing that what it is looking in general. So the first thing is you need to establish connection to Spot programmatically, and then you need to like sort of like know what service you're gonna call and then call the service. So actually create a client and call the service. How do you establish the connection to Spot? So the concept to know here is that sort of like, okay, so here, like this is like the picture of connectivity. So you have like the robot and a bunch of computers, and by default, they are just observing. Like you can sort of like stream camera images and without controlling the robot. And let's say like one of the computer, for example, the tablet wants to control the robot. And what it needs to do is like acquire a lease. And that's how, so like this system knows that this computer has like control authority to Spot. And only one computer can be controlled at one point. But if the other computer really wants to use Spot, it can actually take the lease. So there's like this two different words. One is acquire and the other one is take. It's actually words in the API. So if I really want to like take over the control from the tablet, I can take over the lease, and the other computer just becomes an observer. And programmatically, just an impression of like how this looks. So what happens is that you call create like these methods, and then these are like sort of like steps that you have to do. and then you authenticate the robot and blah, blah, blah. And then you get a lease by, I guess, create a client for the lease service. And I'm gonna sort of go through a more concrete example in a moment, but just give you an impression. So how do you like create a client and call the service? So in this case, like the service we want to call is like robot command, and you create a client by interfacing with this robot that you created earlier when you did the connection. And then these are sort of like fixed things that you have to do. And after a while, you sort of build up the input. You build up like the message type that you need to pass into the gRPC call, or like sort of like the input to the method that you're calling. And then you're just like calling the robot command, which is one of the, I guess, triggers a gRPC call. So, okay, so that's for opening gripper. And so I guess what you can see is like, you're building a gripper command, and then you want to open it. So you sort of like set a opening to be 100%. And then you send this command. And that's like sort of roughly how it looks at a high level. And okay, yes. You build gripper command, and that goes into the command builder to get out command, and then that gets sent. Yeah, so build synchro command is like useful if you have multiple commands you want to execute at the same time. And yeah, exactly. Exactly. Yeah, so basically, right. So what happens is like, this is the definition of the robot command service, and it takes in, actually, no. Oh yeah, one of the RPC call is a robot command. And actually we should probably look at the RPC for this to be, okay. So if I go to like robot command request, so robot command, so you saw that robot command request was a, like the request type for robot command RPC, which was essentially what I'm calling here. So in the definition of the robot command request, you see that you're passing in this command, which is a robot command, and that's a single command. So if you want to like do multiple things, you're essentially using the SDK to build that for you. It's essentially returning you an object that's a robot command. And it actually, yeah, I didn't know this, but it seems to just require a synchronized command. So that's why like a lot of this like ends up you following examples. So okay, control F5. Okay, so it is really useful. Like they give you a bunch of examples that you can follow, and what happens usually, you just look at the code and figure out what you need to adapt. And okay, so I'm now going to do the Hello World demo. This is the first demo, so let's see if this works. It's already it's 4 p.m. Okay, so we still have half an hour for this. I'm just gonna connect to the robot and make it stand up. Yeah, I think it's good if you can move back. Just move back like for this demo, and then you can be closer to the. So now I think it's a good time that I stop sharing the screen so that the recording can get this. Okay. Okay, me too. Okay, so now that the robot has started, I'm going to, it's not gonna really move very much for this hello world example. And I'm gonna reshare my screen so that you can see what I'm gonna do on the terminal. Okay, so I guess this is probably a bit small, but you can, yeah, I think it's okay. It doesn't really matter to see the details. So basically, I'm going to, the way I'm using Spot is really like using the Docker. So and then what I'm gonna do is I will this is when I can zoom in easier. And then in Spot, well, you cannot see the, okay. So in Spot SDK, so this SDK is essentially like the repository that you clone. And in there, there's like a Python folder, and then there's a folder called examples. And then among all these examples, there's something called hello spot that we are gonna sort of go through. And this screen, so, okay, so this is like the code that I'm gonna run. I'm gonna go through the lines later, but essentially you're like sort of running a program with a main function. And I am going to go to the same place. Hello spot. Okay, so the way to run this is, first of all, there is a robot IP that I have. And all you need to do is to provide the robot IP when you run this. There's a way to. Okay, so you see it is saying resource already claimed error. That's because I have the control, like the tablet is controlling it. So what I need to do is to just drive forward a little bit. I'm going to make it sit. And then I'm going to release control from my tablet. Okay, so now if I run this again, it doesn't have that error anymore. And it is, so often what happens in a lot of these examples is like, it's a very end-to-end process from starting off the robot to like doing the thing and then finally turning off the power. So it's just like does this like little movements and then takes a picture, and that's all for this hello world example. So yeah, that sort of give you an idea of like what this hello world example does and how is that actually like implemented. So yeah, I'm just gonna go through this. Basically, okay, so these are some lines that you have to do. For example, like set up the, I guess you don't have to set up the logging, but you have to create a SDK, and you can give like any name that you want. And once you have the SDK object, you create like the robot object. And this is also something that you have to do. And then you do authentication. That's why this proprietary robot, you have to do authentication. So, and then this is also a step that you have to do to wait for some time synchronization. Like there's a clock on the robot, and there's like I guess a clock in the on your computer. And then you do this like, because what we want to do is like control the robot to do some movements. You need a lease, and that's one way that you can use this lease client is like make it available by this like lease keep alive function. And then once you're in here, you can actually do the thing for to the robot. So first is like power on. So this is pretty high level. They made it pretty high level, and then you build a command. So once the robot is powered on, you command the robot to stand. And what you will find is like for different things that you want the robot to do, it's not always the same. Like in this case, I guess blocking stand is a custom function implemented within this hollow spot example. But for some other actions, you may need to do something else. That looks very different. And then, okay, so after it was standing up, it did some rotation. And the way that it did it was you, I guess, specify a rotation like raw pitch yaw, and then you create this synchro stand command, which is basically, okay, so this is one of the commands that you can run in this, like, I guess one of the API calls. But anyway, you get this command and then you send the command. This is sort of similar to the example in the slide earlier. And then basically when you call robot command, it's executing the command, and then you need to wait for 3 seconds. And then this is like when it stood up a bit taller. And so there's like a different command, like that actually it's the same command, the stand command, but it's different parameters. So what happens is like when you're building a protobuf message, you don't have to pass in all of the parameters. Some of the parameters have default values. And in this case, you're just setting the body height. And in the other case, you're setting like the rotation. So yeah. And then this is like an example of capturing an image. And okay, so we are gonna dive into like a closer look to capturing image as an example for how to figure something out. But basically, yeah, and then there's like log a comment. So the impression that you should get is like you have the connection to the robot that's sort of like boilerplate, and then you may need to require the leads, and then you do the sequence of things that you want, and finally you can power it off, or you don't have to power it off. So yeah, I hope that's like the Hello World example. And also, I think I didn't change the camera when I was running the example, right? I kept sharing screen, so the camera didn't. Anyways, it's okay. So, okay, this is what I was gonna run, and then we are done with the Hello World. Okay. So the question is, where do we get the SDK? The SDK is like you can pip install. So the SDK is open source. What the server, like how they implemented the servers are not open source, but like they provide you the client code. So any other question? Oh, so the question is like how is like using the Spot SDK compared with using ROS? What you see is like they sort of implemented a lot of things that has like like I guess counterparts in ROS. For example, they have a system for frames, and then they do like you can do asynchronous calls, but the difference is like you don't have this like publisher subscriber thing that you have to deal with. So this is more like a library that you call. So there's no visualization built in. So that's I'm gonna get into ROS like later, actually, when I talk about robot dev. Okay, so now it's like, how do you figure something out? The answer is there an existing example that just does what you wanted to do? So you can just like sort of look at it. But if there's no existing example, you may want to think about like what services you may want to call, like look at the list of services. This is kind of like demanding, but but you know more when you use it more. So and then like how do you like actually call these services and then process the results? So oftentimes you can search for like that service call within the like library of examples or within their tests and see how they use it. So that's some details. But let's say as an example, I want to stream images from the Spots camera, and what you like the RPC that it provided was only to get a single image. But then what should I do? So let's say in the hello world sort of like example, we saw a code block that was getting an image. But let's say that we didn't know about this. How do we approach it? So what services can we use for this purpose? Okay, so the what I want to like show you is like how to figure out what service to use and how to call it based on just looking at documentation and their code base. So when you, I guess I don't need all of this. So what happens like you may want to like go to this page. And then where you have like all of the protobuf references, actually like here. So, and then because we are dealing with images, maybe you want to search for something related to images. But also like if you're dealing with arms, you can search with something that deals with arms or some along that line. And for image, you want to look at like what services you have access to. And there are only two. In this case, there's like, oops, zooming in will break the scrolling. So there's listing the image sources and also getting image, and that's it. There's no actually like direct service to do the streaming. But that's why like you use gRPC. That's one of the reasons like high performance for a use case when you like need to do a lot of frequent RPC calls. So you can do a lot of frequent like get image calls to do streaming. And okay, so for this example, I'm going to, okay, that's what I was gonna show you. And this is what I was pointing to. And actually, like instead of just like talking it through, I was planning to go through an actual coding example. So that was that's in here, but I need to switch to a different branch. And then so you have this is like the template that I was gonna, okay, this is the working. Okay, so let's say we are gonna implement this streaming image like application. And based on what we know so far, we're gonna start with like some boilerplate of how to connect with Spot. And because we are just an observer, we don't need a lease. So now like how do you actually go about doing what's next? We know that there are just two services that we can call. So so in order to call a service, you need to create a client for it. And how do we know like what kind of client we want to use? So one thing you could do is you go to the examples, like this is all the examples, and you sort of search for, you can do different, it's very bad that it doesn't show the what's in the bottom. So basically, let's say we are gonna use this thing called get image. Can we like actually search for the use of this get image RPC method among all of the examples? And we actually, okay, so we found something, and that is you have this get image example actually, but it is in the comments. So we are lucky that we found it through like the camel case. But okay, so what happens is like once you find something in the example, you can like look at what this example is doing. So so they also did this connection business, and they created a client through like this line. We are gonna do that as well. And okay, so they have this like option dot image service thing, and then that's essentially like the default value of that is this. So this is an image client dot default service. What happens is a lot of like this is sort of like their convention. When you want to create an image client, you call this like robot.ensure client method, and then you need to pass in like the service name, which is like which this class just has a field for that. So now you have this like image client, and then you want to call service. So we know that we probably want to like call the get image service. Actually, yes. So we're gonna call the get image service, and we are let's so one thing you could do is to search in the documentation for that actually image client. This is sort of okay. So there's an image, and in this page, there's like image client. There's something called image client, and one of the methods. So you're sort of expecting that this library that they provide you can make you call the get image RPC. So one of the functions is like get image from sources, but there's also just get image. And we're just gonna call this like this is like the most straightforward. So what we're gonna do is, so this is like the image client, and then we call the get image method. So what we need to pass in is like a list of image requests. And so what you're gonna basically do is like you're gonna create some kind of image request. Let's say we're just gonna do a single get image request, and we're gonna basically create this object called image request. And I'm just showing you sort of how you can figure out the fields to pass in for this object. So okay, so get image request has like this is the message type that we are gonna create called image request. And where does that come from? So because this is a protobuf thing, protobuf object, what you would do is like, for example, in the get image example, they actually have this image underscore pb2 package, which is the result of compiling the proto, like proto sort of file into a Python script that you can import. And then through that, you can get the image pb2 dot image client, actually no, image request. And what we want to pass in is like, here is an image source name. So you need to like pass in the source name, but we don't know like what sources there are. So this is all planned. So I was like, we can call the other service that is provided, which is list image sources. So let's just like actually I'm going to skip the details here because it seems to be a bit too much. But basically, there is this same like function in this library that they provide you. There's a list image sources function that you can call, which calls that RPC. So I'm gonna be like, just call the list image sources, and let's just print that. And then if we run this, actually not here. robot dev stream image work. Oops. Tutorial stream. No, not robot dev. Working. Okay, so it says image client is not defined, and we didn't import it, and we are just gonna because wow, sorry for the chain. I just need the. I cannot see the left edge of the screen, but okay, so there's where you get the image client, and then you run this again. Okay, so now that's the output of list image services, and so the output is sort of like we're just printing it directly, and it's like a list of protobuf messages, and for each of those messages there are a bunch of fields, and what we are looking for is like the name of the service. Like for example, this one, write fisheye image. So we are gonna do. This is our. So going back to the protobuf image request message type, there is this thing called image source name, and we have, wow, and then image source name, we give it the right fisheye image. That's what we saw. So then let's see if we can just call this RPC. Okay, so we did get, so now this is a result of like the get image RPC call. So we actually want to like get the image instead of just getting a bunch of text like this. So how do you do that? Well, you can always look at the example. And I'm so sorry that I have to like move the screen around like this because yeah, I want it to be bigger, but so in this example, there's also a get image call, and after, so what you get from the get image is a list of image responses. That's also part of the definition in the SDK. I'm not gonna go back to that. So what you have is like a list of image responses, and you go through. Okay, let's just make our life easier and just copy this. So you can see that there's a bunch of stuff that you have to do. Just to sort of point out like what it is doing. It is, so if you look at the documentation for get image, so it returns a get image response, and in the get image response, it defines like a list of image responses. That's why in the code this is like that, and each of them is an image response, and each of the image response has like each of the image response has a shard field, a source, and a status, and the shard is like what contains the image. So it's kind of complicated, but that's why you see like, so in this case, the image is the image response object, and then you're accessing like, dot shard dot image to get image, and you get like the pixel format and stuff like that. And I think that the most tricky part of all of this is you need to sort of convert the raw bytes of the image data into a NumPy array, and that's why like it's helpful to have examples, and we just like copy this. So too bad. I lost the copy. So, okay, I need to import CV2 and I need to import NumPy. So let's do that. And let's visualize the image. So and we're just gonna do image show image with a CMap of gray. I have, that's the reason I'm typing this so fluently is because I've tried it. Let's see what happens if we run this code. Okay, so we get this image, which is from the right camera, and it looks kind of crappy, very low quality image. Oops, I want to zoom to make it bigger, but it seems to be, yeah, it's very coarse. So what you can do is, like, if you look at the definition of image request, there's a field called quality percent. And if we set the quality percent to be like 75, it's basically from 0 to 100. And we run the same thing again. And you get a much better image. So you can, so there's a lot of like these kind of parameters that you can set, and it's quite straightforward. You're building a sort of like protobuf message object. Okay, so now this is not streaming yet. So how do we stream? And that's really simple. You know, the most sort of like, I'm not teaching how to stream images, but essentially, like, given the get image, which is like the only RPC call that seems to be relevant, what we may do is just to call that many times. So we are not gonna create a client every time we call the get image RPC, and I think that there's some kind of timestamp for the image request, so we're gonna have to do that every time we stream. So just do a while loop, and then I think there's a way to do this without blocking. So if we just do this, like, so a while loop, and then inside the while loop, you just call the get image RPC. Okay, so I don't know if this is updating, but if I walk over here, yes, you can see the streaming image. So and what's happening is I'm like pausing for 1 second. That's why it's slow. But you can, the latency is very, very low. So I guess what we could try is like 0.05 maybe. So that sort of every time you run the matplotlib window, it blocks like the whole execution thread. So this is like not blocking it, so that we can stream. And then we're gonna do, and let's see. So this, okay, so since I think this is because of the rendering of the image, but getting the image is pretty fast actually. So okay, so that's it for this demo. And what time? Mm-hmm. Which one are you talking about? Get create robot? We can check, but my guess is not, because it's from this SDK. But we can like get robot. yeah, maybe it isn't, but yeah. Anything that require that is like sort of application relevant is protobuf. So okay, that's all for this example. And we're done with it. Any other questions? What time is it? 4:34. Okay. So yeah, if you need to leave, feel free. But I'm gonna keep going, and then at the end we have like extra time for you to try something. So now I'm gonna talk about like robot dev, which is how I have been using Spot. So the motivation is we have different users who want to use Spot, and then we have ROS and Spot SDK or VM. That's another middleware. And for each of them, you like have to install them and then make configurations. And also, but basically, like there's things that we want for each of them, which is like things like object detection or motion planning. So this robot dev is like like a Docker-based approach to system approach to work with robots. And okay, so the idea of this is you have your host machine that could be running a different, like a Ubuntu, let's say 20.04, and let's say you want to like control robot that's running an older version of ROS, and then the only way to use that you have to like use a different version of Ubuntu. So the way that this robot dev handles that is like create this Docker container for that environment for the robot, and then mirror that on your host machine, so that you can like edit all of the code in your host machine with your favorite editor, while the changes are directly mirrored to within the Docker, and also any changes within the Docker could be persisted if the Docker is crashed. So that's sort of like what this is. And we have like this robot dev for several robots. Mostly used is Movo and Spot, and also Turtlebox are sort of like the first getting started thing. But the charger for Movo broke just a few weeks ago, and so the only reason to use this currently is just for Spot. So the pros and cons of using robot dev versus purely SDK is there's a simpler API that you can deal with, you can use, and this ROS integration. Do you have a question? Okay. And then it's Docker based, so you don't need to like configure anything. But there's a steeper setup curve and it's not official. So, okay, so I'm going to show you some demos of using this. And the first one is streaming image. So sort of doing the same thing that we were doing before. And then I'm just basically going to show you like the code that I wrote for streaming image with robot dev. And let's first run that. Robot dev stream image. Okay, so this is streaming the front image, and obviously, yes, it is updating. So it's also printing like the latency of getting the images, like 0.1 seconds. But you can see it's sort of like it's much shorter. Let's just compare it with the default one that we were working on. This is like similar to what we were working on. And it's the same thing. So you establish connection, but in this case, you have this like RBD Spot package. And then you just like create this single object and that's it. And you don't need to do all of this. And then for image, you can create an image client, and then you just call this get image thing, which gives you the result. That is still a protobuf object, but then the point is that there's some convenient methods in this library, not just for streaming images that make your life easier, but also like it's totally totally reasonable if you follow the official examples and use their SDK directly. So that's like the stream. And then the other thing I can show is the like how to build a SLAM map and then do navigation. So this library, I wrote the library. Yeah. So okay, so the way that we use, so now like this, I'm in a Docker container, like the color of the shell is a bit different from outside the container. And all I'm gonna do is like, because like a lot of the functionality is sort of ROS integrated, even though it is independent from ROS, like the package that was imported is actually a ROS package. That just makes things more organized. And I'm gonna do the mapping. So first of all, I'm going to make this bigger, and then I'm going to take control on the controller on the tablet, and then make the robot stand up. Okay, so now once that's good, the way that you can run mapping is just perception refnav mapper, and then let's say this is like spot CIT 122 121 tutorial. Okay, so this is sort of like a standard interface. I didn't write this. This is just using an example and wrapping around it. And what you could do is just type in some numbers to, okay, we first start recording a map. And the way you sort of build a map is so simple with Spot. So you just like drive it around. And what you want it to do is sort of detect some of these fiducial markers, which are helpful for like these black and white AR tags, helpful for localization later. So I'm gonna just drive it around, and if you don't move, it should be safe. So let's say we do this. This is really crazy. Wow. Okay. So now we build the map. And then stop recording a map. And then there is automatically find and close loops, close all loops. And then optimize the map's anchoring. And then when I click 5, it is downloading the map. Okay, so now it's downloaded, we can quit. And now we can visualize it. This is like, it's essentially like RobotDev has this convenience script that just does this thing in end-to-end fashion. I don't know how to zoom in with the trace pad, but well, but this is the map that we were built. So these are the people, and this is the screen, I think. Okay, so that's like the mapping. And let's say we want to do navigation. So you can do navigation like the way that I'm gonna show you is like the example way, like using a script that Spot SDK provided. I'm just wrapping around it. But RobotDev also has functions to do that. But basically, I'm gonna run RobotDev Spot perception, and then nav. And I give it the name that was like CIT 122 tutorial. Okay, so the reason that this isn't working is navigation requires control. So I think the navigation in this case may be a bit risky because it's more cluttered. I'm just gonna release the. Hmm? Yeah, let me try to like set a pose that's not too far from it. So let me get my mouse. Okay, so I'm just gonna, so now there's no control and I can run the same code. Okay, so first of all, get localization state. Is it localized? And it seems to be localized because it's outputting some pose. So what you could do is with this interface, just to show you like how navigation sort of looks like, you can navigate to this 6, which is like navigate to a waypoint ID. And how do you know the waypoint ID? So you can type 4 that lists you all of the waypoint IDs. That's why it's like somewhat inconvenient. I don't know, where any of these waypoint IDs are. So the way I can figure that out is through visualization. So I have this like, okay, so RBD spot perception. There's a maps folder, and if I do view map, and then Boston Dynamics CIT 120 tutorial. Interesting. Oh, I typed 1121. I wish this map is still functioning. Did I type 1121 for this as well? Sorry, please. I didn't. So that's a different map, and we don't want to do that. So let's use the map with a typo. I believe that is okay. Bye-bye. Sorry for a second. This is I just want to make sure that this is 1121. Okay. So if I do the navigation with 1121 and I get localization state, list the waypoints, and I view it. Now I can zoom in. So these are the people. The spot is probably somewhere here. So if we set a waypoint that's like waypoint 2, it's not going to be very far from where it is now. So let's try that. So the short code, so the interface basically takes a short code. So waypoint 2 has a short code ED. What you do is like in this interface, just navigate to ED like that. And it's probably gonna move very little. Okay, cool. So that's the navigation. You can, it can be pretty accurate. You can set a tolerance. I'd say like, I can show you another video to show the accuracy a bit later, but it is pretty accurate. Okay, so that's the mapping and navigation. And then what I wanted to say is like this function in RBD spot package that's like high level, like navigate to some kind of goal, and then you can use it in your script. So for the ARM, I have another example for the ARM that's implemented through RobotDev. And the ARM example is like this. So I'm importing RBD spot, and that's all that I'm importing. Besides, I don't think, okay, I'm using block and stand to just make it stand. And then this is actually, it would be good if you guys can back off a little. That would be, thanks. It's gonna move forward by 2 meters, and yeah, but you don't. Other people don't need to move. That's it. So, so the kind of like API that's in this library is like move any factor 2, or move in any factor 2 with body follow. So it's pretty high level. And if we run it, so Python Spot robot dev ARM example. Not powered on error. Okay, so I'm going to hijack control, power it on. So even though I'm controlling the robot within the script, so it needs a lead, but I didn't write like the power on code. So I'm powering on here, and then I'm just gonna take over the leads within the code. So I'm gonna sort of like just run this, and then you will see basically like this gets changed to an observer, and you see like, so this is what it is gonna do. It's gonna reach to some place that it cannot reach at first, and then it's gonna try that again with body follow. So this is all like sort of like high level RPC call provided by Spot SDK, like the body follow thing. So yeah, that's the example I wanted to show about the ARM, and you can feel free to sit back if you want. But okay, so yeah, that's okay. So the final thing, okay, so this is like the functions I was talking about, and then ROS integration. So I'm just gonna show you how ROS integration looks like, or like how it works. So I'm gonna do first get state, which is just I have some commands here. So robot state publisher. So getting state is just an observing function because it's just so getting the poses or joints. And now this is running. I can run Arvis. And in Arvis, we have nothing right now. But if I set the fixed frame to be one of the frames for the robot, like flat body. No, flat body is like a frame on the ground that is not affected by like tilting the body. So okay, actually, if I add a robot model in this Arvis, you see the robot there, and then I can essentially like move it around, and you can see it moving in the ROS. So okay, so this is like the ROS sort of getting the state. And the next demo I want to show is to stream sensor. We did a stream sensor with like programmatically, but how do you like visualize it in ROS? It is actually is also possible. So I'm just gonna run. First, I have a script that streams image. I'll actually just stream the front camera sets, and then I'm gonna do Arvis. So perception stream. Actually, not ROS run stream camera set, front camera sets. Okay, so this is streaming the front cameras. Okay, so it is not running because there's no ROS core. But if I run Arvis, there will be a ROS core. Okay, there's no ROS core if you run. You can run a ROS core and then run Arvis, and this should be starting. So it is streaming. The thing about this is like it starts pretty slow, like 1.5 seconds, but it actually gets faster and faster. Maybe that's the power of gRPCs, like going from 1.5 seconds to 1 second, and it's gonna keep dropping. So we have the same Arvis like interface, and then we set the frame to be, oh, I forgot to stream. We can stream the robot pose again. State publisher. And then, so what you see is here is you should get the other frames, and then we're gonna add the robot model back again. And then we have topic. I guess we are going to actually by topic add depth cloud from the left. Okay, so this is like the depth cloud from the left camera, and we can add another one that is from the right. Okay, so maybe this is not the right one. It should be the depth in visual frame. Okay, it is pretty real time. If you like move around, then it should, yeah, it should change. Okay, you can see you. And there's no color here, but you can actually add color. And you have to like type in this. I don't know why you have to type in, but I don't exactly remember. But just to give you an idea. For example, like for the left image, oops, left image, which is, I'm gonna do it here. Okay, so now you see color. That's, you just like, it's really easy in ROS to visualize these kind of things, and very helpful for debugging and stuff. Okay, so that wasn't it. There's also localization, and I'm gonna stop the streaming. But then I'm going to, oops, it seems like there's some trouble stopping it. Okay, so I'm gonna run this. First, drive the robot to face well. Okay, so at this moment, the robot lost internet connection. I don't know why. Okay, maybe the last example cannot be run in right now, or if I use a different controller. Actually, I don't know why this is. There were some temporary networking issues, it seems like, but it's fine now. So, okay, it's fine. And I'm just gonna drive it to face a fiducial marker. And then I'm gonna run, oops, this ROS Launch RVD spot perception. GraphNav publisher with localization. Map name. is the CIT 1121 tutorial. And instead of Arvis, I'm not gonna run Arvis. I shouldn't kill ROS core. I'm going to run this ROS launch RBD spot perception view graph nav with localization. Okay, so I think the reason this isn't working is because I killed the ROS core. Let's do this again. So first I'm going to run the state publisher, and then I'm going to run the localization, and then run Arvis. Okay, so you see this is a point cloud that was collected, and this is a location of the spot. So if I drive it around, actually it moves in the map, and it can be pretty accurate, I think. So this is, seems basic, but it is really useful and not so easy actually. But you can like, it seems, yeah, that's like, yeah, that's I think this is enough. Yeah, it is. It's not affected by the chair. Like the environment changed, but like the mapping localization is still working without the chair, exactly. So okay, so that's actually everything. I should just wrap up with the slides. I'm going to stop all of these. And okay, so that's all for. I was thinking that this will be end earlier, but it seems like we are almost out of time. I don't know what time it is, but we can try this later. Like if you want to like set this up on your computer, it's you can always set up the Spot SDK on your own computer. That should be easy. If you want to do the robot dev thing, it's the best if you have a Ubuntu. I've only tested it with Ubuntu. So yeah, that's all. And do you have any other questions, Anuba? So yeah, the question is, because Spot is sort of gRPC based, can you just sort of figure out the send a request through reading the documentation? I think principally it is okay, but I think robot really needs authentication. That's why like in the script, it's like robot, you need to create a robot object that's authenticated, and you create a client by ensuring the client. If you just call it without authentication, it's probably not going to work. Okay, so it's like a user and password. Yeah, so yeah, that's the authentication. Any other questions? So are you asking, the question is like, if you're sending many commands, how does Spot synchronize it? I don't know. I think there this is I don't really know, but there's probably a timestamp that like everything is timestamped, and then if let's say you send a command before the previous one was complete, it's probably gonna just not perform the command. Yeah. So Yeah, question is like if you receive another method. So I think it depends on what kind of command you're calling. If you're like doing multiple ARM commands, it's probably not gonna be able to do them together. But you can totally like run navigation asynchronously while doing some ARM movements, because they actually have like they have asynchronous calls, like they all their RPC like SDK methods. You can do it asynchronously. So like for example, you can even like list image sources asynchronously. So if you do this and you can do something else, and that should be fine. Right, it has to like, I don't know about the waiting. You may just like, it's probably gonna wait until the succeed. Yeah, you can try it out yourself. Yeah. Cool. Yeah. So the question is whether the collision avoidance is activated if you do it, if you control the robot programmatically. And it's, yes, it's always like activated unless you turn it off. So can you say that again? Oh, yeah. So the question is like, how do you emergency stop the robot programmatically? So the way that you should do it is like, there is a e-stop button. That's one of the examples that you can run. I think I should have run this probably, but in Spot SDK, in examples, Python examples, there's an e-stop. Okay, there's e-stop, and then there's e-stop GUI, and I don't know how exactly to run it, but host name probably just robot IP. If you run the operation is not allowed when motors are on. Oh, so but basically, let's say let's try this out when we turn the motors off, and then we try this e-stop. Okay, I don't really know what's happening. So I think so. I didn't prepare for this demo, but basically there's like a button. If you run like this script, there's a big red button you can click, and that's usually when a robot running into an emergency, you just like e-stop it. You know, on the tablet is like this button that you click. So anyway, yeah. Is there any other? Is so the question is like, if your computer loses connection to the robot, does the robot still have connection, network connection? Keep running something. Um, let's say like if you're running navigation and during navigation your computer shut down. I have never tried that. I don't know. I think it will probably keep running until, because it's like receive the request. It's also possible that the Spot like it requires some kind of like acknowledgement, like constant acknowledgement with your computer, and if it's not connected, then it will just like shut down. That's also possible. I don't know. 90 minutes. Yeah, it's just gonna like fall down in whatever way. Yeah. So you can actually like swap the battery live. You can watch tutorials for that. Yeah. Okay, I think we may be good. So yeah, I'm so glad that it seems that everything is recorded and everything works. So I'm very happy. I hope to not have to do this again. But I can if someone needs me to. So I can share it to the Slack. Yeah. Okay. So let's do it. Stop recording.